Smart Culture, Mathematics.
Let's learn more about the cosine ratio. The cosine ratio, denoted as cos, relates an angle in a right triangle to the lengths of its adjacent side and its hypotenuse. So for a given angle theta, the cosine of theta will be the length of the adjacent side divided by the length of the hypotenuse. Remember, the adjacent side is the side that is next to the angle but is not the hypotenuse. So what we'll do next to better understand the cosine ratio is we'll take a look at 4 triangles. Let's take a look at the first one. For angle A, the cosine of A is equal to 4/5. And this indicates that the side adjacent to angle A is 4/5 the length of the hypotenuse. The triangle is relatively flattened, meaning angle A is smaller compared to the other angles in our list. Let's take a look at the next triangle. Here we have angle B. So for angle B, the cosine of B is equal to 3/5. The side adjacent to angle B is 3/5 the length of the hypotenuse. Angle B is larger than angle A, but smaller than C and D, given its cosine value. Let's take a look at the next triangle. So for angle C, the cosine of C is equal to 2/5. Here, the side adjacent to angle C is 2/5 the length of the hypotenuse. You'll see that angle C is steeper than angle A and B, but not as steep as D. Now, let's take a look at the last triangle. For angle D, the cosine of D is equal to 1/5. So the side adjacent to angle D is just 1/5 the length of the hypotenuse. So among A, B, and C, angle D is the steepest, and its cosine value is the smallest, but still greater than 0. Now, let's learn more about the boundary values. Consider an angle of 0 degrees. So this will be a flattened triangle. At this angle, the adjacent side and the hypotenuse are the same because the triangle collapses to a straight line. So the cosine of 0 degrees will be the length of the hypotenuse divided by the length of the hypotenuse, and that equals 1. What about an angle of 90 degrees? For a 90-degree angle, the side adjacent to it has no length. It's a point. So the cosine of 90 degrees is equal to 0 divided by the length of the hypotenuse, so that will be equal to 0. Let's visualize this on a number line. You'll notice that as theta increases, cosine of theta decreases. At an angle of 90 degrees, cosine reaches its minimum value of 0. So as the angle theta in a right triangle increases from 0 degrees to 90 degrees, the value of cosine of theta starts at 1 and gradually decreases. By the time theta reaches 90 degrees, the cosine of theta becomes 0. And our given triangles, with the angles A to D, showcase a progressive increase in steepness and a corresponding decrease in the cosine value. So this pattern illustrates the inverse relationship between the angle size and its cosine value within the range of 0 degrees to 90 degrees.
And that's a wrap on today's fascinating journey through the world of knowledge. Don't forget to hit that subscribe button and join our ever-growing community of curious minds. We can't wait to embark on new educational adventures together.